We'll start in about a minute. You want to do the intro, the beginning things, or care? Okay. All right, we'll wait for Richard to get situated there. All right, well, let's get started. Welcome to the Friday sessions at the IETF. Thank you for sticking it around. This is the MLS working group. We got 2 hours scheduled. As usual, we pulled together the agenda at the last second, so hopefully you're furiously downloading slides to read them. Again, it's Friday, so hopefully you've seen this before. This is the note well. For IPR related things, it's kind of if you know something, say something. There's a bunch of other things that are listed up there, like anti-harassment, code of conduct, etc. Read it, know it, note it well. If you got any questions, you can ask the chairs or an area director. Note the really well. This is basically, treat each other with respect. And that's what we're hoping for. You don't have to like anybody's, you don't have to love everybody's ideas, but you need to treat them with respect. Meeting tips. Please make sure to log in using the on-site tool or the full tool to make sure that we get an appropriately sized room. Friday, this seems to be about the right sized room, so that's good. Cullen is jumping in the queue. No, he's not. Okay, good. So we're also going to use this to make sure that we can moderate the queue with remote participants, because we have a lot of people that are already in Toronto for real world crypto, and some that will be going shortly. All right, cool. Resources for Brisbane. Hopefully you've seen this. This is our agenda. I put this in here so I can remember to ask for a note taker. I do not need blow by blow minutes. Oh, awesome. Thank you, Jonathan. All right, cool. So blue sheets, we got a scribe. Agenda review, this is where we're going to bash it. So we have a couple of active working group drafts. But the big thing we have to get through, we have one remaining item left in the MLS architecture draft that we kind of need to decide today and then move on. And then our AD can hit the IETF last call button and we can get it out the door. We'll discuss that. There's kind of two options. Then we got a couple of drafts. I'm not sure if we'll get updates on extensions or federation, but I've listed them there anyways. And then we have a bunch of individual drafts or ideas. Britta Hale's going to talk about post-quantum hybrid design trade-offs. Richard's going to do a little reminder about MLS credentials, which we've already talked about and basically had agreement to adopt as soon as we get our charter done. And I guess I should say that the charter getting done is kind of conditional on us getting the architecture document done, because that was the deal we made with the ISG, was that we would get our first set of deliverables done before we moved on. I did a bunch of extension work, but that's life. Then we have some MIMI related drafts. It's the first protocol that's going to kind of adopt MLS and run with it. So we got a couple there. And then we have some additional ones for, how to make it lighter, because that's what we do. And then some additional things from Conrad about virtual clients and paired MLS. So we should have time to get to all of these. So I'm going to jump back. Is there anybody that wants to bash this? Is there anything that's missing? I know that Rowan, you sent some slides about additional extensions, but I think we can just kind of glom them all together and talk about them, because you're pretty good about one slide, one thing, like moving on. So, all right. So on to the interesting stuff, which is this MLS architecture question. So on the list, we sent a message out about how we're going to fix this problem. So we have a recommendation for doing encrypted group operations. And the interesting thing is the first protocol at the gate that's going to use MLS is not going to follow the recommendation. So there's really two ways we can fix this. There's two ways we can fix this. One, which is to change the recommendation, to provide more context around it, et cetera, which is something that we talked about at the interim. And the other thing is to provide some additional words and then remove the recommendation. I would like to say that I think this is not a hill in which anyone should be trying to die, but this is the last remaining issue. And I'm curious if there's anybody that wants to add anything new to the discussion that's happened on the mailing list. Yeah, sure. I want to accept my own request for scare slides. MLS, is it this? Nope, it's not that. I'm going to allow it. I was actually going to try to show you the text. Of course, I hit the wrong one. What is this? Explain the impact. All right, cool. Share screen, accept. So I'm using this one primarily just because it's got all the text there. So the text is on the left, and the recommendation is this thing that we prefer using encrypted group operation messages to avoid privacy issues related to non-encrypted signatures. And one suggestion is to remove the recommendation and provide a whole lot more text about it. Hopefully you've had a chance to review these already. I didn't really want you to read them now. And the other one is to keep the recommendation and provide some additional flavors around it, like other things you can do for mitigations. So I guess the question is, on the mailing list, there seems to be slanting slightly one way. Is there anybody that wants to get to the microphone to add anything additional? Because otherwise we're just going to make the call and move on. I don't know, is there anything in the chat room? Chat, I haven't seen anything. Sleeping. Hi Deidre. All right, so I think what we're going to do is this is extremely rough consensus. This is kind of how it works in the IETF. I think what we're going to end up doing is landing 246 and closing the other one out and calling it a day. And so Paul, this hopefully will be in your lap shortly. Sorry? No, I mean, I don't know what Ecker's workload is like today, so he may do it, but you don't need to hit the button before SAG. And by the way, I appreciate you dealing with all those errata I've been firing at you. All right, cool. So we'll get that issue closed, and now we can move on to the exciting stuff. And me stopping sharing my screen. So, Britta. Oh, Ecker?
So to confirm, I'm going to push the merge button right now, or you're going to push the merge button.
Can you do the merge and then spin a new version, and then when Paul gets to it, he can do an IETF?
So Paul said he wants it before SAG. Is that what he said?
No, he said he wants it after. He wants it after SAG.
Okay, I can do it after SAG.
All right, I really appreciate it. Thanks, man. All right, cool. So Britta, you are up. Do you want to run the slides, or do you want me to?
You can go ahead if you've got them. That'd be great.
All right, cool. Post quantum and MLS. Here we go. All right, cool. Just say next when you want me to.
Sounds good. Well, hello, everyone. We, the group of us, Joelle, myself, Marta, and Susan, have been taking a close look at post-quantum MLS, and particularly hybrid post-quantum MLS, and what these trade-offs are and how they can be optimized. So today, what we really want to do is get some discussion on where people would be most likely to lean in terms of implementation. And we're going to show a few options and approaches. So next slide. So approach number one, this is Rowan's current draft, dealing with basically a hybrid chem. It is great that we are taking this on, I'll say, just as a first blanket statement. It is good to be moving on post-quantum now versus waiting for like the optimum solution. But there are trade-offs, and we're looking at the trade-offs here. So this hybrid chem approach is basically that you're having classic and a post-quantum chem cipher suite. And when you update, you are doing an update to both. All right. So there is an efficiency cost that comes with this. And the question is, are you always willing to pay that? Or, of course, in some implementations, it could actually discourage doing updates if it is too costly. So how could you potentially ensure that you're getting post-quantum security in your implementation, even if you don't want to charge that post-quantum update all the time, but you do need to be ratcheting forward? So we're in this discussion, we're just going to leave authenticity out of scope for the moment. Of course, in this approach, it is out of scope, period, and it's focused on chems. So that's roughly approach number one. Now approach number two. So next slide. So the second approach that we are looking at is what I'll call session combiners. Essentially, you can think of this as you have two parallel MLS groups, completely distinct. You have your traditional one and your post-quantum one, and you are going to combine them by using exporters. And we just discussed this some in the interim, a few trade-off points, but we've delved into that more, and hence this discussion today. This could, of course, not be a perfect match on the sets of participants. You could have the post-quantum group to be a superset. So for example, maybe you have a post-quantum group with all members of your organization in it that rolls every once in a while. And you are going to use exporters from that as injects into all of the participant groups throughout the organization, and all these smaller traditional groups, traditional MLS groups. And so you actually are able to get some post-quantum security in these traditional groups. Or you could alternatively match participants one-to-one. So there are, again, some pros and cons. A nice pro to this is that you can combine any two chems, so we don't have to be locked into one cipher suite now, or if that cipher suite changes, that you only have, you have to standardize a whole new cipher suite. So you can combine any two chems, whatever your post-quantum is and whatever your standard is. It's also very efficient in the sense that you can do lots of classic only commits and updates without incurring a cost on your post-quantum. So think about this in terms of like what Signal's doing now. Of course, Signal's doing a hybrid post-quantum approach, but they only do that in the initial handshake. So they don't do any of the ratchets with post-quantum or hybrid post-quantum. So you're only getting that property out of the very start of your session and nothing else after. And of course, in approach number one, you're getting that post-quantum ratchet at every single ratchet. So this is sort of landing right in between the two, where your post-quantum ratchet can be dialed like a turn dial to as frequently as you can manage, or dialed back if you can't handle that overhead, but you can keep your standard ratchets going no matter what. It's also very nice as a pro that it is modular. We don't need to change anything about MLS or current designs therein. It is really a matter of the delivery service getting pieces in play. Now the cons, and I see Rowan at the mic. I'll hold on to the end of approach 2. And there is approach 3 if you want to hold your thoughts until then. So then you got 3 of them to look at. So the cons here are that your DS has to handle management of all this, right? You've got potentially 2, or you might have a larger super group of post-quantum, and you need to be able to figure out what to export or when, as well as managing commits and stuff in between, and whether or not these need to be synchronized and so forth. So there's a few decision points, and we're not kind of delving into all the decision points here, but there are the cons in terms of the DS. Rowan, do you want to take your question now or wait till after approach number 3?
Yeah, hi, Rowan May. So this is a clarifying question. So this would provide protection against harvest now, decrypt later for even if the post-quantum group is has people in it that are not in the main group and vice versa, right? It would still provide that protection.
Right, so that depends. If you want to do a very, very strict version of harvest now, decrypt later, you will match the set participants. That doesn't mean matching ratchet frequency, but you just match the set participants. If you're talking organizational internal and you assume that no one in your organization has a quantum computer that they want to hack their neighbor's group with, then you could do the superset and still have that property.
Okay, so in other words, if the attacker isn't in the group, then you're safe from harvest now, decrypt later.
Yeah, so long as your attacker is outside the post-quantum group, you're safe.
Okay, thanks.
And of course, you can match participants one-to-one if you want to just be outside of the group in question. Richard, do you want to take that question now or wait till after approach number 3?
No, wait, he said wait, or go ahead.
Wait, okay. Then let's go to approach number 3. So approach number 3 really flips this on its head. It is, instead of putting the weight on the DS, we're going to try to leave the DS mostly alone and be more invasive on MLS. So in approach number 3, you're essentially looking at 2 chems, keys per node. And you get very similar properties in some ways with the approach number 2, and the fact that you can combine any 2 chems. They don't have to be a set cipher suite. You can also do classic only ratchets without having to do the post-quantum ratchet if you need to reduce the frequency of the post-quantum one. And there's a little bit of a bonus here in terms of you only need to deal with one MLS session. There isn't a second session. So in this case, you are absolutely matching participants one-to-one between the two groups, if you think of it that way. The cons, of course, are with that we get invasive with MLS. In terms of we actually have to make some changes to what the protocol currently is at. Of course, we have to handle 2 KIM keys. We need to be able to know when one updates or when one is called for an update versus 2 and so forth. So there's a few trade-offs among these 3 approaches. And what we're really looking for from the group is where is everyone's leaning most towards? And again, I'm not addressing authenticity here yet. All the factors in. I'll wait till next slide. I'm going to take a quick pause for some discussion. But what sort of direction is going to be most useful in practice for the different implementers here? And what are the trade-offs you're thinking of? Richard looks like he's up first. So you still want to?
Yeah. I'll jump in now. So thanks for this presentation, Britta. Just for what it's worth, I went ahead and implemented a Cypher suite based on the X-Wing combiner with MLChem and X25519 in MLSPP and ran some experiments. Turns out that it doesn't actually seem that expensive. In operations, in a realistic scenario where we had certificate chains, the ratchet trees and key packages only ended up 60% bigger because certificates are already so gigantic that the giant MLChem keys are just more weight. And the processing times were I don't know, low double-digit percentage points slower. So it's not a huge impact. The main thing was that remove commits got a lot bigger because of because there you don't have key packages, you don't have certificates. So you feel the impact of the bigger public keys a lot more and the bigger ciphertext. So in my mind, it might not be super urgent to do a lot of this optimization, but it's useful to have these in mind. Among these approaches, I think approach 3 probably appeals more to me, and I think we might be able to do this even within a single cipher suite. You could potentially have a single cipher suite with 2 ciphertext formats where the sender could choose whether they're going to send a PQ plus normal plus classical ciphertext or just a classical ciphertext, and then the receiver could handle them appropriately. We could signal that in the protocol. So I think we could do this actually pretty smoothly.
Great feedback. Yeah, in terms of efficiency, that really is probably going to factor more when you're in those sorts of use case environments where you really are counting bandwidth. But probably we're anticipating, when I get to the next slide, is the factors once we hit authenticity that is going to pop up. It's useful feedback about approach number 3, though. And we can discuss whether or not that flexibility with the 2 chems, maybe you want to pop up later again, but flexibility with that 2 chems, then if that's not so much of a bonus that's worth keeping versus having a single cipher suite.
Yeah,
I'll let you think about that again.
Yeah, so I was going to ask from the floor, but I'm lazy, so I'm prepared at the front. Just the impact on size. If you're running 1, it's big. If you're running 2, interesting. I'm just curious to see what the actual data was. So thanks, Richard, for running that stuff. Rowan?
Yeah, hi, Rowan again. So when I was at Wire, we implemented the Kyber X25519 combined cipher suite, and had basically this was faster than our implementation of P256. So in terms of speed, it wasn't a big deal. And likewise, Wire just introduced end-to-end identity certificates. So similar, things got marginally larger compared to adding certificates. So yeah, approach 1, I think we should absolutely do approach 1. And then the question for me is, what else should we also do? And it seems that for approach 2, if you want to do approach 2, the only thing that you actually need from the MLS working group to do approach 2 is to register an MLChem cipher suite a non-hybrid cipher suite. And that you could even use a combined cipher suite because X25519 is so fast. So you wouldn't even necessarily need to do it. You could just go and have the cipher suite from approach one in one group, and the MLS spec already lets you go and do this. And it would just be like additional guidance saying what the security considerations were and when you should export the key and import the key at various times. I was also curious though, I know Joel had expressed some ideas that were sort of riffing off of approach 3 that would allow reuse of some of the parameters across groups. I don't know if you wanted to comment on that or if that's something we just kind of leave for future work.
Do you want to comment on that?
So largely, I think I agree with Richard's comments. Namely, like obviously we should do one because it is essentially no work. In fact, so I don't think that having rigidity about the ciphers is a bug. I think it's a feature. I don't want to have a common to work explosion of ciphers. So I think that having them be glued together is a feature, not a bug. Two scares me. It seems like very hard, like to reason about, and hard to manage. I think Richard's point about 3 being effectively like, effectively isomorphic to 1, and like is right. I mean, one can imagine in fact doing a new cipher suite that literally was just a hybrid and only had like and either an always active helming key and sometimes it had an empty MLChem key. And again, that could be like more or less hidden from the implementation otherwise. So I think it really could be just contained in the cipher suite if one wanted to do it. But I would suggest the right thing to do is to simply define like X2 the same set of like pairs everyone else is doing as a new cipher suite, and then see like how that goes.
So then the question with 3, mind you, there's a note on here that 2 and 3 are under this long-term plan thing, and that'll come in when we get back to the authenticity. But as people continue to think and jump in the queue, are there any reasons why you would want to do classic only update in this hybrid construct versus doing it always as a paired classic and post-quantum?
As far as I know, the only reason is it's like is a smaller bandwidth, right?
Well, yes, naturally. So, are there reasons? Like, do you have use cases where you would use that?
I don't.
So, this is Daniel Kahn-Gilmore. Thank you for presenting this range of stuff, Britta, and thank you, Richard, for actually running some tests. It's great to have the data. I said this in the chat, but approach 1 seems like the obvious thing to do to me as well. I think the kinds of complexity that we layer in with number 2 is like a whole other protocol on top of MLS, and I don't think we should be doing that. We've got enough to worry about with MLS itself. And as far as this idea with approach 3 that you can, sometimes use a classical only combination, whether it's for size or for computation or whatever, I can't imagine. I certainly can't imagine asking the end users when they would want to choose those things. That just seems like a user interface disaster. And I don't really see how you would set a simple policy for doing that. So, and it just seems like it's a lot more mechanics to worry about. And I strongly think that simplify, and approach 1 seems simple, not too expensive. Let's keep it that way. Thank you for presenting all the stuff.
Okay, so we have this rough overview that we're kind of liking approach 1, and we like the simplicity. Now I'm going to throw a curveball into this mix, and we'll go back to the mic after I present the curveball. So what about authenticity? So under approach 1, again, we've tied these updates together. And in that sense, if we're planning for the future, eventually we need to be planning for authenticity. There is a natural first question that is a prelude to all of this, which is how much do you care about authenticity? And I imagine among the working group, there'll be a whole span. There will be people who say, hey, I'm going to do classic authenticity forever and ever. There will be people who are going to look at post-quantum authenticity, but really at the last possible moment that they think they can get away with for their implementation. There will be people who say, I want to roll to post-quantum authenticity now, but I really don't care enough about hybrids to be bothered. But in that case, you probably aren't doing a hybrid chem either, right? And then there's the all the way down the spectrum to the actually we want both hybrid for authenticity, whether that's in transition or eventually. And just like we're doing a hybrid chem approach, and like approach number 1, we will probably, whether that is now or you're thinking in 2 years from now when standards are nicely cleaned up, that you would be looking at having a hybrid signature of some variety, whether that's 2 signatures or combined. And I'm going to punt the question of what a hybrid signature might look like and just say right now we're talking about 2. So that's a spectrum between classic all the way through post-quantum to pure combined. So first, that's the first thing on the list. Second is then all of these approaches change up a little bit once we put in the options. So assuming that you want to do at least a post-quantum signature, if not a hybrid signature, now under option or approach 1, you are going to always be using and taking on the cost of those hybrid signatures. Under approach 2, now you can decouple them a little bit and say, I'm going to do classic signatures for the most part until I need those post-quantum at the time I need them. And those signatures would be very separate, like the post-quantum chain only has post-quantum sigs and so forth. Under approach 3, you can do a variety of things. You can still do 2 signatures, 2 different signatures, and update separately. You could also do a hybrid signature so that your standard one is always taking a combined hybrid approach, which might defeat the purpose of going to approach number 3 over approach number 1. But at the very least, you could kind of decouple that a little bit. So then kind of probably going back to Richard's question earlier, I don't know if you tested with hybrids or post-quantum SIGs in this implementation, but if we're going down this pathway, is that ever going to become a problem? Like, are we going to circle back to this in a few years' time and say, actually, we need to do something about post-quantum SIGs now, and we should probably have that in our hybrid approach? We wish we'd planned for that earlier. What is our scope here? First of all, where'd you land on the spectrum? And then now reflecting on the authenticity piece, which approach is going to become more desirable under that?
Rowan May again. Britta, do you think that there's a difference between how important it is to use post-quantum signatures for your identity signature versus your ephemeral signature? For me, it seems this is a fairly big difference.
Mm-hmm. So I think there's probably a time consideration to that as far as how critical it is in time-wise. Obviously, we talk a lot about harvest now and decrypt later sort of things, and identity probably rolls less frequently. But then if we're talking far enough down the line, then maybe the difference becomes less. So we are talking here about big picture, planning for the future. What would you be interested in? So back to you. Just that hot potato back to you.
Yeah, so I would say, like, if I've got a key package that's valid for 3 months, that protecting having a post-quantum signature that covers part of the key package, that's more important to me than signatures inside of the MLS group, where presumably I can, once a week or once a day, or once an hour, I can update my keys, and then I would need a pretty fast adversary in order to be doing quantum operations and that, cracking my traditional keys in that time frame.
So in terms of the first two questions I asked on where in the spectrum you'd fall and what approach you're looking at, did you want to wait on this before I let you go from the mic?
I guess the middle one eventually.
Okay.
So I feel like maybe we need to be a little clearer about the threat model here. Like if there's a viable cryptographically relevant quantum computer, then like you have to use post-quantum signatures for everything all the time, right? Does everybody agree with that?
It was really hard to understand you.
Yeah, I think you.
Sorry, I said if there's a viable quantum computer that can actually is like able to attack our classical algorithms, then all the signatures will have to be post-quantum, right?
So that goes for both the chem and the signature. So I'm not going into the debate of like where on the spectrum of development of post-quantum we're at, or when we're expected to have that, or the trade-offs as far as we probably won't have an absolute attack, but we can have sufficient partial attack to exploit these. But the fact that we're going for a hybrid chem already means obviously the group is concerned that there's some leeway time that we need to be cognizant of. So in the frame of mind that we are already taking on that leeway time that we're cognizant of, now what about signatures?
Well, as I was saying, there's the lead time for the chem is because of harvest now, decrypt later attacks primarily. It's not primarily about like deployment timeline. So I guess what I'm getting at is if in the there are two reasons why one might get ahead of the curve now on the signatures. One is if you think that, as with the chem, that things that are signed today will actually be an issue if there's a post-quantum, things that are verified today now and signed today now will be security relevant in the future, and therefore you're worried at the signature being broken later. And the other is to get deployment ahead of the curve. And I guess what I'm saying is that in the long-term future, if we actually have a cryptographic on a computer, the answer will have to be that everything will be post-quantum, and you won't be able to do hybrids some of the time and post-quantum the rest of the time. You have to do post-quantum all the time, right? And so the relevant question is, what are you getting by trying to do classical some of the time and post-quantum some of the time? And so that depends on the assets are being protected in. And it seems like the assets you protect, the two assets that are relevant here are, one, the key packages and things like that, and the authentication for the group joining, and the second is the message is the messages themselves be able to create ambiguity about the signatures and the messages, right? But the second one is like a short-term consideration. The credentials are a short-term consideration, namely that having the signature on my key package be valid a year from now is not particularly useful, and but they constitute only a small fraction of the signatures that are of the security bandwidth, and so I guess I don't understand how we're going to get any benefit at all if we have post-quantum signatures by not signing the messages.
Mm-hmm.
Other than
a lot.
Sorry, go ahead.
Yeah. So one thing that we should be considering here is this case of new algorithms, new post-quantum algorithms, and that whole, hey, are they vetted enough? What surprises are in store? Now, you already mentioned if there's a post-quantum or a quantum adversary, we can assume that you can pretty much just erase your classic side, right? But that doesn't solve the problem of, do we fully trust the post-quantum side yet? And this is that sort of niche area that everyone always discusses in when it comes to signatures. But that does take us into that eventual threat model down the road that we're looking at. So suppose there is a situation that we now have a quantum computer. And suppose that quantum computer is in an adversary's hands, like a state adversary. So not in your average hacker's hands, not in your average adversary's hands, but there are adversaries around the world that may possess it. Now, how do you protect against this? If we just say, okay, that means that our classic is gone, we might as well strip and go straight to post-quantum. All your bets are naturally in that post-quantum basket in terms of that state adversary. But what about all the other adversaries that are in question? For those, you may very well still be relying in some degree on this classic side, because if that post-quantum wasn't as reliable as you would have liked, maybe you've lost as far as the state adversary goes, but you haven't yet lost as far as all the other adversaries. So obviously there's refinements to this, and each of implementations, each implementation is going for a different adversarial case and a different concern. And I think really what we're getting towards here is, in that, say, a few years from now, where are those concerns going to be? Will any one of these approaches still be more attractive than the other? Like, is it that we choose one approach now and stick with it indefinitely? Or should we kind of have a couple approaches? What is that going to be? So over to you.
Yeah. I mean, I guess what I'm trying to get at is what's expensive here is the post-quantum algorithm, not the classical algorithm. We could afford to have the classical algorithm in perpetuity, and it would make no meaningful difference, given the currency of the post-quantum algorithm, make no meaningful difference in the cost of like how expensive everything is. So the question is, under what circumstances do you use the post-quantum algorithm? Whether it's in hybrid mode or a standalone mode, that's the expensive part. And so I guess what I'm getting at is that the versions of this where you're like, oh, we're only going to use the post-quantum some of the time, I don't think make any sense, because the sum of the time, the thing the thing that optimizes it is not signing the messages, but that's the only thing that's worth having long-term security for. And so I just don't understand like how we get to some of the time. That's what I'm trying to get at.
Okay. Next in here.
Deirdre?
For simplicity's sake, having PQ only cipher suites for signatures might be nice to write down for the ones that want to agree on them for their groups. Just that was a thought. Also, are there any concerns with credentials being hard to rotate between hybrid and then eventually PQ only cipher suites?
This is Richard. Yeah, to Deirdre's question, I don't think that there's any. It's not obvious to me there'll be much difference in credential rotation based on the cipher suite. Actually, the reason I enqueued was to say that like the signature algorithms are not the only problem here. It's the question is also like, what do the credentials look like? And that's a lot of why I think this is a problem for like IETF 130 or so. Because there's a like it is seeming increasingly unlikely to me that we're just going to like do X509 with some different parameters and have like giant ass, SLH DSA certificates, and just pass those around. The things like Merkle tree certs, like people are actually doing some interesting innovation in what credentials could look like with this Merkle tree cert stuff and whatnot. So like I think the credentials are actually going to look pretty different. Yeah, there's a fair chance the credentials look pretty different when we actually get the PQ authenticity algorithms in. Now that said, the authenticity algorithms we use internally to MLS is not necessarily coupled to the credentials. All the credential needs to do is talk about that key. All right, so you could have an ECDH certificate whose subject public key is an SLHDSA public key, right? Then you use the SLHDSA or MLDSA key inside of MLS. That's a little more plausible to me if folks wanted to go ahead and start using that internally to MLS, but I wouldn't worry a ton about the credentialing schemes at the moment, because I think there's a bunch of uncertainty there, what the credentialing ecosystems are going to look like in the near future.
All right, cool. I think we drained the queue. I think the discussions will continue. Thank you, Britta.
All right. Certainly. And if anyone would like to weigh in on the list with this, obviously there's some trade-offs and people will think about it a little bit longer. And maybe there's something to come back to later, but basically that was our authenticity plan. And so far it sounds like definitely no, we like approach 1. Is that something that we should be statically holding to? All right. Thank you very much, Sean.
All right. I think we're now going on to additional credentials. So that was a very nice segue. I don't know if we even planned that.
Excellent segue. Thank you, Sean. So this is like a one slide presentation. You can go to the next one slide. So we talked about this in San Francisco 2 IETFs ago. You know, there's a bunch of interesting work going on around verifiable credentials to make credentials for users easier to issue off of things like OpenID providers. So that was the genesis of this draft. And then it seemed like it might be useful to be able to present multiple credentials, so like one of these verifiable credentials that proves your SSO login identity as well as your identity within the particular app you're using, a certificate chain. So there's also a scheme in here for multi-credentials. It has a nice indirection, as we were discussing in the chat just now. You can use that to indirect things and have a little bit of signature flexibility. So yeah, that's what's in the draft. We had an adoption call after IETF 117, which indicated positivity, and I assume I think you're going to do a recall after the recharter is finished.
Yeah, I'll appropriately word it so you have to really object. But yeah, because we basically already did it.
Yeah.
So yeah, it's essentially in my mind adopted already, but we should go through the process like we're supposed to go through the process.
So this is just a reminder presentation for everybody. There's no change to the draft since last summer. So yeah. There you go. Happy to take comments or questions if anyone has them, but there's nothing new here.
All right. Rowan, I think Rowan, you're up next. Make sure I get the right slides. Additional credentials, like clients, virtual. Is it all of it in the more MLS extensions?
Yeah.
All right, cool.
Next slide, please. Okay, so I thought that Richard was going to go before me with talking about extensions for Mimi, but basically there is a set of stuff that we described in the Mimi working group as possible MLS extensions for sharing room policy and participation lists, among other things. And Richard has a presentation to talk about this. In addition to that, there was also 3 other areas where it looks like Mimi might want to have some additional otherwise generic functionality in MLS. So I already discussed briefly the key package context at the previous IETF. I also, a couple IETFs ago, described the self-remove proposal. The main reason for the self-remove proposal was to handle a generic problem in MLS, which is that pending proposals don't show up in external commits. Maybe we want to solve that more generically. And then I also had a sort of a draft fragment for how to have other ways of conveying the information about the ratchet tree or group info. So next slide, please. Okay, so the key package context draft. So this would be an extension that says you only want to use this key package in a particular context, for example, in the context of a specific MLS group. Only for someone who wants to add this key package with the following user identity, only if it's used by someone who wants to add you who has a user identity in a particular domain, or only someone who has who wants to add you that has a particular public key. So those were some contexts that could be used. And Brendan asked on the list, why wouldn't you just do this at the application layer? The reason is that if you are going to generate your key packages and upload them to a server, you may not have real-time communications between, let's say you have two users that are in different continents and different time zones, and someone says, hey, I'd like to invite you to the group. Could you please give me consent to add you to the group? And then a few hours later, this person, they're offline, and the other person wakes up and they say, yeah, I'll give you consent. And by the way, here's a key package. But in case I go offline, I need to put that somewhere. So that storing a context with that key package and having it signed and bundled into the key package, that could provide some value. I think it makes these kind of subtleties about how key packages get used more explicit and safer. Okay, so I was hoping we were going to discuss that general app state thing first, but this could be done just as this could be useful in the outside of the Mimi context and just be used as a key package extension. It could also be incorporated into the concept of app state in that you could have, you could extend this concept of app state and say, we want to be able to add application specific state in key packages in general. And then we would just do that once, and then you would use the sort of application ID to say, I'm adding app specific information to my key package with this application ID and this application ID. Ecker.
Yeah, I guess I'm not finding this motivation particularly persuasive, I have to say. Like, this seems like exactly the kind of thing you want the application to do, and the application is, I don't understand why you couldn't do exactly the same thing, but with assigned object at the application layer.
Okay, let me ask you a test question. So if I have a Mimi application, so I have an application that is connected to a provider that speaks Mimi.
Yes.
What do we say in Mimi to the provider to make sure that the client gets this information safely, where Mimi isn't specifying the provider to client protocol? Mimi specifies a protocol between providers or among providers.
Yes.
Okay, so
but it also specifies a messaging format.
Well, the things which are specified by Mimi that are between that are end to end are the message format and a profile of MLS. So if it's not,
so you put a control message in the message,
and it's not something that was encrypted with MLS.
No, but it is encrypted. It is encrypted with MLS, right? Like, how are you playing this in the first place?
What's this?
What? Maybe I don't understand what your plan. You want to convey something from Alice to Bob, right?
Yeah. So Bob wants to say, I'm going to allow this key package to be used only for Alice, for example, or only for Alice's domain. So if Bob isn't, this happens before any end-to-end encryption between Bob and Alice, obviously. because this is about getting the key package that's used to bootstrap the end-to-end communication. So Mimi doesn't really have a, doesn't have a place to go and say, yes, between the provider and the client, this is what Bob needs to do in their proprietary protocol to convey this. But Mimi can say, here's a key package extension. If you use this, it has these semantics. And if you want to have these semantics, you use this key package extension.
I feel like I'm really understanding the problem statement. So maybe we should take this offline.
Okay.
But until I do, I'm not going to be signed on probably.
Colin.
So I think that I would be sad to see us. So Mimi has lots of things that you trust the providers to do, lots of authorizations and things. The one thing you don't trust them with is to read your messages, but you do trust them to help set up the communications and form all the relationships together. So I would hate to see us try and embed the whole Mimi protocol inside of extensions in MLS. I don't think we should do that. I think it's a very bad separation. And I'm not really following why this particular thing can't be secured by effectively there's a TLS connection between the two providers, because it's not really between the endpoints. Right? It doesn't have to be secured at the endpoint levels at the threat model I'm thinking about in Mimi. But maybe I'm wrong on this. Like I'm not saying I deeply understand that, but I did try and follow that. I guess I don't also understand what a domain ends up meaning in the MLS context. I mean, if we're doing it, this says the context of a domain, but I don't know what a domain is here when we're talking about an MLS extension, right?
I was referring to a DNS style domain. So,
but what does that have to do with MLS? Like, what's a good one? What's a bad one? What do you do with it? Like, how does this work?
Well, in this case, this would be if the user in Mimi doing the adding. So it's a particular domain, right? That's why.
Okay, so I think this this extension assumes something that isn't agreed upon in Mimi, which you are arguing for, but isn't agreed there yet either, right? So I don't know. I'm not finding this hugely motivational yet.
Okay, I mean the concept of users having a domain associated with their provider that is in the MLS architecture, which we talked about already. 2 ITFs, 3 ITFs. In any case, I'm going to just say one more thing about this, which is that, it's fine for Bob to be able to go and negotiate with Bob's provider to say, hey, I only want this key package to be used in this context. But Alice also needs to know when Alice gets a key package, whether this key package is going to be relevant, whether Alice can use this key package. And so that is something that needs to be coordinated across vendors, across systems. And that's why I think we need to have some mechanism to do that isn't entirely within the purview of the provider client to provider interface.
Agree. I'm just not fully getting the motivation that needs to be secured by MLS. That context can be part of the application context around is what I'm thinking. And look, I don't know. I'm just sort of suggesting we look at it. That's what's confusing to me about it. That's
okay. Yeah, maybe I'm just not smart enough to see a way to do that using the available key information that we have with the, so we can take that offline. Brendan.
Hey, so I think I do understand your argument about needing some plumbing between client A and client B to be able to communicate. But I would ask, in terms of the abstractions that Mimi has, I feel like that plumbing should be client A communicates to provider A their restrictions in a provider-specific way. Then Mimi has some way to communicate those restrictions in a standardized way between provider A and provider B. And then provider B communicates the restrictions to client B in a provider-specific way. Is that not how Mimi would be meant to work?
From provider A to provider B, I think that would need to be in Mimi, certainly. And yeah, I've yet to see an existence proof that I think can do that in a safe way for a key package, because the key package is how we get the bootstrapping of the, of the keying material that we need to do most end-to-end things. So
Right. And
Like I said, maybe there's some clever way of doing this that or even not so clever way that I missed, but we can take this offline and try to figure it out.
yeah, I mean, there's no security. I mean, if there is a security reason to have these constraints signed in the key package so that they're bound and so that they can't be forged, that would be a really good motivation to actually put this in the key package. But without that, it feels like it could be communicated just alongside in the provider specific way, like I said.
Okay, next slide, please. All right, so a couple ITFs ago, I produced this self-remove proposal extension. The original reason is that a user removing itself can't guarantee that this is going to be an atomic operation. A user could send a remove proposal, and then an external commit could come in and require that user to be able to go and send that some arbitrary number of times. And in conferencing scenarios, we actually saw this in a real implementation where sometimes it would take 3 or 4 commits before the person trying to remove themselves was actually removed. Basically, this is like on the hour, a bunch of people leave and a bunch of people join, and it ended up in some pretty ugly client functionality. So the self-remove was a proposal that said that the external commit is obliged to include this in external commits. However, if we made an extension which said, okay, this means that generically valid pending proposals need to be available at the DS, and an external committer needs to go and include those in an external commit. This would be a more generic way of solving this problem. And it wouldn't require adding a new proposal in order to do this. It would be sort of a one-time thing. And in the cases that Mimi is using, and like other cases where you have an external commit, the external committer already has to go and fetch a group info. So fetching a list of pending proposals is also not really a big deal. It's something we could easily do. Next slide, please. So just a note here, this would not be a safe extension under the extension framework. Does anyone want to say anything about this? Does anyone have an opinion about this? I would tend to want to go and solve this problem generically. If there's pushback that we don't want to solve this generically, then I won't bother, and I'll just go forward with the self-remove proposal.
All right, good. I figured we were going to get Richard up at some point.
Richard, I never really liked self-remove, so I kind of like doing it generically better. The only thing that really gives me a little pause here is that, allowing, if you look at this only within the MLS envelope and what logic the MLS client is going to apply, this looks like allowing arbitrary proposals in external commits, which feel, I think in the context you're thinking of it, it makes sense because you have some semi-trusted authority managing the queue of proposals that are going to end up there. I just wonder how we appropriately cabinet so that we don't open up arbitrary changes in external commits. Although, I mean, maybe we could get comfortable with that even.
Yeah, I mean, I think that there's a way to, in the same way that we have in the commit section of the MLS spec that says this is the order in which you go through the commits and how you establish that these are valid and self-consistent. And a proposal that on its own would have been valid may be invalid because of the existence of a previously validated proposal. I think we can do that same thing for this. I think we can do it safely and, make a nice, clear explanation of what is and is not valid. And also to your point about the, like this, I can imagine a way to do this that doesn't have a sort of a centralized DS where you have sort of a, you have clients where they sort of, one of them take turns, or one of them is sort of, elected to become the thing that decides whether proposals are valid or not valid. You could do it with that. And so you could still use this extension in that context, but you wouldn't have to. And if you had something that was fully distributed, you would simply not use this extension, not advertise this extension. Brendan.
So I was thinking that I believe canonically in MLS, the users themselves or the members of the groups or the members of the group are the ones that are able to decide if a proposal is valid or not. And this seems to potentially move to a world where the DS is the one deciding if proposals are valid or not. And I guess one point in favor of self-remove is it's slightly easier for someone outside of the group to be able to say, yes, all of the users agree this is valid. Whereas if you're including a bunch of pending proposals, you do have to trust the DS to properly enforce access control.
Mm-hmm.
But if you are in that world, then just as well.
Next.
All right, next.
Okay. This one I'm going to go over real fast. I submitted a fragment of a draft today. Just be on the lookout for it. I'm not asking for any discussion about this, but right now we have a ratchet tree extension defined so that if you want to include a ratchet tree, the entire ratchet tree of a group inside of a group info or inside of a welcome, you can do that. And it's RFC 9420 says you can also have that information conveyed externally, but it doesn't specify any way to do that. And there are, of course, as a result, no security, security considerations for doing that or anything like that. Many vendors have designed a DS that basically reconstructs the ratchet tree and more or less reconstructs most of the group info, with the exception of the two pieces that it can't get, which are the group info extension external pub and the group info signature from the previous committer. So this just defines some objects, some structs as sort of, throwing spaghetti on the wall. Do we want to have a more formal definition of some of these other ways that a lot of vendors are implementing so people do them safely and consistently? And we may also want to reference those in Mimi. Next slide. Britta already asked questions about post-quantum. So I guess the question is, if we ended up with, most people leaning towards alternative one in her slides, does this mean we want to, pull for adoption once the charter is updated? Yeah. Richard, did you have a question about this or the previous?
Yeah, this one, let's do it.
Okay.
All right, I'll count that as a pre-early thing. I'll let Nick jump in.
Yeah, I'll just say that this draft has a dependency on a ID that has not been adopted.
Yeah.
All right. Okay, cool. Again, apologies. I think I did some presentations out of order here. So
That's fine.
All right. Richard?
Well, a minor amendment on prior comment level. Let's do some hybrid chem thing here. Like if it's X-Wing, great. If it's something else that comes out of CFRG, do that.
All right. We're going to do AppSync. AppSync. So, by the way, good placement of the logo.
I've got a whole Google Slides theme now that uses the official colors and everything.
Great, I'll borrow it.
Yeah, I'll send it to you. All right, next slide, please. So Mimi, you may have heard of is this group we're doing to do messaging interop. One of the things you would like to have in a messaging situation, you've got a messaging room where you have a bunch of clients and users interacting, you'd like to confirm that everyone in the room has the same view of who's in the room, what their capabilities are, what the state of the room is, etc. Now, we're using MLS for the end-to-end security for these MIMI rooms to end-to-end encrypt, so the servers in the middle can't decrypt them, decrypt messages. But MLS also provides this group state agreement property, where everyone in an MLS group agrees on who's in the MLS group, what their credentials are, etc. So the concept here is, let's reuse that state agreement property for application state as well as MLS state. Next slide, please. So yeah, the idea here, the way we envision, the way this is in the current draft, the MIMI working group is on the cusp of adopting, is that we communicate state change. We attach a thing to a group context extension to the MLS state that captures the state of a room, right? So a room has an MLS group attached, and so we'll take the state of the room in some format and attach it to the state of the MLS group. And then changes to that state, so adding a user to the participant list. The participant list talks in terms of users, not in terms of clients. And so adding a user to the participant list is not inherently an MLS operation, right? Because you're not talking about a cryptographic thing, you're talking about a permissions thing. But we've added a proposal here called AppSync that captures the change to that application level data. So you basically, this proposal for AppSync is a way to import changes into at the application layer, to changes to application layer state into the MLS control system. And by virtue of that import, that proposal now becomes part of the transcript once it's committed, and then flows into the key schedule. So the same confirmation stuff that confirms everyone agrees on the MLS state also then confirms that everyone agrees on the application layer state. Next slide. This is concretely how it's written up now. There's a couple of ways you could imagine designing it that I've got on the next slide. But basically, you make a group context extension that describes the application state in a couple of possible formats. It's either opaque, or it's a map, or it's a list. And then the proposal, this AppSync proposal, sends diffs on that state. So you send either a replacement opaque state, you send some removed or updated keys if you've got a map, etc. You'll note also at the top there's an application ID. The idea is that you could have multiple types of application state that you're tracking here. In MIMI already, we have two types. We want to track a policy document, we want to track a participant list, and have separate parallel state management for those. But that's the totality of the concrete mechanism. Next slide, please. Now, you may have noticed there's a big select there, like, are we going to how is the state structured? Is it opaque? Is it map? Is it ordered list? Is it unordered list? I think there's a basic question as to whether the state that the application is importing into MLS is intelligible or opaque to the MLS layer, which kind of informs what the API is that you need between the application and MLS. So if the state is intelligible, then these diffs come in these AppSync proposals. The MLS stack can apply it to the copy of the state that it has and go ahead and compute the new state and include the new state in the key schedule, and then just kind of report out the diff or report out the updated state to the app. If the state is opaque and the diff format is opaque to MLS, then MLS has to basically pass the diff up to the app and ask, hey, what's the updated state that I should import? Now, you could just import include the diffs in the key schedule and not the updated state. That may be good enough, but you might also want to report back a hash of the updated state as a result. So there's a couple of designs that you can envision here. The current draft has the left-hand one where there's some intelligibility, but there's also some extensibility arguments for having opaqueness. I think the next slide is the last one here. Yeah, so this is described oh yeah, sorry, go ahead, Ecker.
Can you back?
Yeah.
So I don't think, unfortunately, intelligibility gets you out of this bidirectional arrow situation. And the reason for that is that not all state updates are permissible. So imagine that imagine that one of the things that you're updating is the user list, but you have an access control mechanism that only allows some people to do kicks and not others, right? So you can't have a situation where a non-administrator can do a kick. And that means there's a state proposal to MLS, but actually what has to happen is it has to get rejected by the application if it's impermissible. Now, that doesn't tell us necessarily how we handle this at the MLS layer. My point is that I don't think you can just have like the MLS thing, like, like just reports up to the app what changed. I mean, unless you want to like basically destroy the group entirely on failures, or
you could wrap checks out. You'd have to like wrap any permissibility checks around the outside of that.
Yeah. I mean, there's sure. Yeah. You can also have another box below that is like, is this permissible thing? But the bottom line is that the application logic has to be involved in determining whether a given update is permissible, as far as I can tell.
That makes sense.
Rowan May. So the MLS already describes how, just something like Alice removes Bob from the group, or Alice adds Bob's client to the group, that how an application layer would use how MLS would consult an application layer for authorization for this type of thing, and I think this is no different. The question is whether it needs to also consult the application to understand what is beyond just a that's okay or that's not okay. It needs the application layer to say, and this is the value of the thing that you end up with, including in your group context.
All right, last slide. So this is just kind of capturing the state of the thinking where we are on this. We've got it in a draft in the MIMI working group right now, that the working group is, like I said, on the cusp of adopting. We had a nice positive adoption call in the room, which is being confirmed in the list right now. If the MIMI working group ends up taking that draft, the MIMI working group is forbidden by charter from developing MLS extensions. So we'll be getting a request in this working group to do some work vaguely of this character that allows application state to be imported into the MLS key schedule for confirmation. So this is not asking for this working group to adopt anything right now, but it's looking like we'll have some work of generally this flavor coming in pretty soon. Okay. Any further questions or comments? Yeah, that's it.
Don't go too far. Light credentials. Light clients, sorry.
Yeah.
All right, we're gonna have plenty of time, Conrad. Don't worry. All right, cool.
I can be pretty quick on this. So next slide, please. So this is some work I've been doing with Franciscus Kiefer and Karthik Bhargavan at Crispin. The problem we start from is scalability. In a lot of applications, we're worried about groups that have multiple thousands of clients in them, and there are a couple. While MLS is designed to be scalable in certain ways, there are certain things in it that still have linear scaling, and linear scaling with constants that are big enough that it gets to be painful. And the two things that get to be particular pains are that when you join a group, you have to download the whole ratchet tree and validate it. And then when you send a commit, you only care about one MLS ciphertext in the commit, the one that has the path secret that's encrypted to you. But you have to download all of the ciphertexts that are encrypted to the whole group in order to validate the signature on that commit. And like I said, in large groups, this gets to be pretty painful. So a tree is gets to be several megabytes. We send them gzipped, which helps with the cert chains a little bit, but only to an extent. And the point is, like, you have to download all of these megabytes before you can join the group. And so if you're joining a meeting and doing this in a real-time setting, you're like sitting there waiting for several seconds while all of this downloads and validates. The situation is less acute for commits, but you get similar size things there. Next slide. That's all downloaded, and of course you have to store the tree once you have it. So you could imagine devices with small memory having problems with this as well. So the solution we've sketched out in this draft is an idea of light clients. So A light client is, a variant of your normal MLS client that behaves in a couple of different ways. The major difference is that the light client doesn't download or keep a copy of the ratchet tree. That should cause you some terror. Pause, we'll come back to that later. It's a trade-off. In particular, a light client can't make a commit because the client hasn't verified the tree to know who they're committing to. They can't process normal commits because they don't know where in the tree they are. They don't know, what the structure of the tree is to understand a commit. Instead, what we do here is we rely on a little assistance from the DS. So a light client joins only from the welcome, doesn't need any further information. It needs a little information I'll talk about in a second. And then when there's commits happening in the group, to enable these light clients to follow along, the DS is relied on to take a full commit with a whole bunch of ciphertext and slice out just the right stuff to send to the light client. So we have a light commit structure that has just the stuff that the light client needs. Now, there's a little bit of innovation here, because the light client doesn't get the whole commit, and so can't verify the signature on the commit. So instead of verifying the signature on the commit, you end up verifying the confirmation tag, which verifies that you've processed everything correctly and you're in the same state as everyone else. Karthik and company have done some analysis to prove that's okay. I'll omit the details for now. But the upshot of all this is that a light client is in fact light. It gets a welcome. The welcome comes with a couple of proofs that have login scale, but like instead of the usual login in the good case and linear in the worst case, we have a hard order login bound here. It's never more than login. And so you have much lower requirements in terms of the time to join, the downloads that you have to make, and the stuff you have to keep in memory. Next slide, please. A couple of corollaries to observe here. I thought were kind of interesting. You can't have a group that's all light clients. You have to have at least one full client, or else you can't let anyone in. You can't commit anything. You could also envision some scenarios here where clients go between light clients and full clients. Like you might join as a light client, download the tree in the background, and then upgrade yourself to being a full client. And now you can participate more fully. You just have to download the tree and validate it. But the important thing is the client the DS needs to be aware of which clients are light so that it can do that commit slicing and provide the light clients what they need. Next slide, please. Yeah, this is just kind of cartoon of what that all looks like. When Bob joins as a light client, he just gets the welcome. He doesn't get the ratchet tree. And then the commit that adds Bob, if there's some light clients around, the light client just gets a commit. Diana should also be light. So Charlie and Diana, the light clients, get slices of the commits that are tailored for them, and Emma, being a full client, gets the full commit. Next slide, please. One of the nice little data structures that's in here. Oh, Conrad, did you want to jump in?
No, sorry. Yeah, just a clarification question. So that means Bob will never recover from a compromise. So if Bob can't update, there's no PCS. Is that correct?
That's correct. So the light clients cannot send. Well, actually.
You could send an update proposal, I guess.
Yeah, I think the light clients can send update proposals, and so they can PCS update that way as long as someone else commits it. Yeah, that's a good observation.
Okay, cool. Thanks.
Yeah, so one of the cool little data structures here, our tree hash thing looks kind of like a Merkle tree. It's got a couple little extra dangly bits, but it broadly has the same structure. And you can do proofs in that scheme, much like you can do proofs in a Merkle tree. And so these light clients, even though they don't have the full tree, can still do specific authentication of specific members in the group using these log depth proofs of membership up to the tree hash, which the client gets in the welcome. So when I say that the welcome the light client gets is log depth, this is why, because the welcome has to include a proof that the signer of the welcome is in the group, so that you get one of these log depth proofs for the issuer of the welcome. And of course, the client would like to know that it itself is actually in the group, and so you get a proof down to that. So we have some need for some of these, but you can also envision doing some more innovative use of these as, to have a client that is light and has, minimal information, but may still authenticate some specific other clients in the group that are meaningful. So if you're in a web conferencing situation, you might authenticate the active speakers and not worry about everyone else who's listening. So this is kind of a useful tool for getting a little bit of authentication, even though you don't have the full tree. Next slide, please. So yeah, this is a proposal to make things scale even better, to basically have unlimited, much more unlimited scalability with hard login guarantees at the expense of trading off on authentication, right? A light client gets much lower authentication guarantees about who else is in the group until they download information to authenticate the other clients in the group. Technically speaking, the main changes we need, you express the skipping the tree validation, you have this scheme for slicing up commits, and then we define this scheme for tree slices for specific authentication of other clients and integrate that in a couple of different ways. So I don't think this draft is pretty 0-0. I don't think it's ready for adoption today, but I would love to hear if this is a problem and an approach that seems interesting, folks. Questions, comments?
There was lots in the chat room.
I cannot see the chat, so
Yeah.
I can scan back through it in a minute. But.
All right, cool.
All right.
Okay, all right. Oh, Daniel. Sorry, Rich.
Sorry, I just wanted to mention something that I said in the chat there, which is that I would be worried about introducing this for what I would consider to be, small to medium-sized groups. Like I can see why this is an efficiency gain for a very large group, and for a very large group, the idea of actually authenticating all 1,000 other members seems maybe implausible to me anyway. Certainly from an end user perspective, I don't know what it means to authenticate 1,000 people in a group, but I would be pretty wary if we were encouraging people to join small groups of size 12 in this light mode. I don't see much of a gain efficiency-wise, and I see a lot of a risk by comparison. And so, if there's a way to cabin this to something above a certain cutoff or something, I'd be interested in hearing what that cutoff would be.
Yeah, I think that's totally how I would envision doing this. Like you would not use this for a group that you can easily quickly download and easily fit in memory. I mean, I think in fact a lot of the ways I'm envisioning deploying this, you only basically use this light clientness temporarily while you're getting yourself set up, so you can join the group fast and then let the authentication guarantees follow in a little more relaxed pace. But yeah, I think we should absolutely have some clear security considerations about the trade-offs that are involved here, because you do lose stuff, and when it's appropriate to take on those trade-offs. Yeah, Brendan. Oh, sorry, Bob.
I disagree with the size limit, because I do have a specific use case where, as I mentioned in the chat, I have very low bandwidth spectrum being able, which is being used for telemetry, and now I need to add in during the operation another member. There's a level of trust already for that other member adding in, and the member does trust the group that is joining. This may make it possible for this to even be used, or otherwise it would MLS is just something I have not really worked with at all for these very narrow spectrums that I'm constantly getting in discussions with. Yes, there are cases where we have broad spectrum, where we have 802.11 radios or something similar, but there are also cases where our only spectrum is 100 kilobits per second. And then that's mostly for telemetry. So yeah, I can use something like this.
Yeah, this could be advantageous depending on what your PHY layer looks like, and your network layer looks like. If you have a broadcasty looking thing, then your overall efficiency might be better to do commits. If you have a bunch of one-to-one channels, then this may be smaller. Brendan?
So there's one security issue here that I think maybe could potentially cause an issue. Because you don't see the whole ratchet tree, you're not able to verify parent hashes. Mm-hmm. And because you're not able to verify parent hashes, you don't necessarily know, just because someone is in the ratchet tree, if they are actually in the group or not. Like, people could forge groups and say like, oh, someone's a member of the group, and they're really not. And so at minimum that has UI constraints that it introduces, and that you can't say someone is a member of the group unless you actually see a message from them. So that's worth considering.
No, it's a good point. And in fact, that's why there's a hard binary between light and full clients. I went back and forth with Karthik a whole bunch about like, couldn't we just like download the copath, a proof of my copath, which would be enough for me to send a commit. And he had to keep reminding me that if you do that, you can't verify all the parent hashes, and so you don't know that you have proper integrity to the tree. As far as the utility of these tree slices, the specific authentication, I will defer to, let me connect you and Karthik on that, because he did do some formal models on that that I think showed that things were okay, but we should dive into that for sure.
All right, we drain the queue. Conrad, you are up next, sir. I think so. Virtual clients and application messages. Yep.
Yep. Okay. So yeah, we talked about virtual clients. I think last IETF or one of the interims. Sorry, can't remember. But if you go to the next slide, we recap real quick on what this is, what we're trying to do with it. It's essentially allowing one or more MLS clients to collaborate in simulating kind of a higher level MLS client. And this enables essentially this mechanic where you have an MLS tree with a bunch of leaves, and underneath the individual leaves, you essentially kind of have another MLS group that well, emulates the client that's in the leaf of the higher level group. And they use an MLS group to do that. And yeah, if you go to the next slide, which I think just reveals, oh, no? Yeah, there we go. And so the motivation for this, the initial thought behind this was, okay, we can use this for users where each user has a bunch of clients, and this serves two purposes. On the one hand, it makes the trees smaller because we have fewer leaves. So let's say we have a bunch of users, each user has a bunch of devices, and so you have a bunch of leaves in a kind of high level group with multiple users. But if you use virtual clients, then each user is represented by only one leaf, and you have these small individual groups for each user that is invisible to all the other group members, and you get away with more efficient commits because the tree is smaller. But another advantage is also that it hides the metadata. So same use case, we have a user with multiple clients, and now the other users in the group cannot actually see which of the users' clients sent a message to the group because the clients are hidden in this subgroup. But the one user, multiple clients use case is not the only one. What you could also do is you could use this to implement kind of organization hierarchies where you have a kind of a company level group with the different departments and the leaves, and then each kind of department leaf has its own MLS group where you have individual teams, and then it's trees all the way down essentially. And that can again make kind of these really big groups more efficient if you have some sort of a structure behind them. And then finally is the idea of guardianship or paired MLS, which Britta proposed in a separate ID as well, where you have kind of a strong and a weak client that are connected, and also in a separate way. I think Britta can maybe say more about this after these slides. They're connected using, I think, a shared RNG. But anyway, you have a strong and a weak client, and the strong client can do computationally more intense tasks and kind of support the weak client in gaining security. And then you can use the kind of virtual clients conceptually to hide this from higher level groups. But yeah, suffice it to say, there are a couple of use cases where this might be useful. And again, if you think of the post-quantum use case, where updates get more expensive, the larger the tree is, and you have to store more public keys. Those are all. This is another situation where you're really benefiting from smaller tree sizes. Okay, next slide, please. And so if we're thinking of sticking with this kind of one user, multiple clients use case, the clients of the user now have to coordinate a little bit in terms of how they, what the virtual clients that they're emulating actually does. And so in most cases, this is already dealt with by the DS, which is kind of dictating the message order. And so you cannot, the individual emulator clients cannot actually kind of cross the screens and do things simultaneously, because the DS will reject one of the commit messages and the other client will have to try again. And that the rejected client will have to try again. But this only really works for commits. And so what do we do in the case of application messages? So let's just imagine for a second if two of these kind of user devices send an application message at the same time, it's going to be the same epoch and the same generation. And that's pretty bad, because now they use the same key and the same nonce, and that's no good. And so what can we do to fix this? Next slide, please. And right, so there are kind of two ways of looking at the problem that Brandon really nicely kind of worked out, and that is you have a kind of functionality problem where if you send two messages at the same time, then the recipient will only be able to decrypt the first message, then delete the key that they used to decrypt for secrecy reasons, and the second message arrives and they cannot decrypt anymore. That's not a security problem, that's just a usability thing or a functionality thing where you just cannot decrypt the second message. And then the second problem is this kind of key nonce reuse problem that might leak the message, or that will leak the message, I guess. Okay, next slide, please. Right, and so I think by now, and we have three kind of different solutions for this problem, and each comes with advantages and disadvantages. And I'd just like to hear if people are interested in this virtual clients concept, then like what properties or what advantages or disadvantages would you like to see in a solution for this application message problem? So the first one is that among the first solution to this problem is that among the user's clients, they have a allotted kind of, yeah, sorry, Ron? Did you want to wait until the end of the
Finish the slide.
Okay, so each client has an allotted kind of generation that they're allowed to use. So let's say there are 3 clients. Then the first client will use the 0th generation, and then the 3rd one, and then the 6th, et cetera, et cetera. So it's kind of modulo, the generation modulo the number of clients. And so this means that clients don't kind of use the same generation. This is nice because it works with vanilla MLS. So the receiving client doesn't have to know that there's a virtual client involved. The DS doesn't have to do anything. We don't have to use any extensions. The disadvantage is that the receiving client will have to retch quite a bunch of times depending on the kind of messaging pattern. So let's say the user has 10 clients and only one client is really active. Then after 10 messages, the recipient will have to retch it like 100 times and keep all the kind of intermediate key material, because they don't know if those are messages they missed or if the other clients may send messages in the future. So that's a bit suboptimal from that standpoint. Yeah, Rowan.
Yeah, so in terms of the leakage, even if this group is stable, it's only if somebody sends multiple messages in a row that it's really obvious with what even the size of the hidden tree is, right?
Yeah.
So this doesn't seem terribly worrisome, and it seems like you could use decoy, basically empty messages sent randomly that could make this even less leak even less information. So I like this one.
Okay, cool. I mean, yeah, you could probably not go with kind of a modular approach where you send every ith message, but instead you have some sort of seed where you kind of just draw randomly, depending on where you are in the group, which generation you're assigned. So there's probably a more clever way to pick the generation that a client is going to use. So, but yeah, but from this slide, you can already see the advantages and disadvantages go along the lines of, can we use this with vanilla MLS, which would be really nice, because then anyone who wants to use virtual clients can just do so, and the recipients don't really have to know anything about it. Then the second one is, will the DS have to do something to accommodate this thing? And then finally, like, okay, if we can't use vanilla MLS, can we just have an extension, or even like a safe extension to do this? And then finally, do we still get this metadata protection where the recipient doesn't really learn anything about the subgroup, the user's clients, essentially. Okay, but let's move on to the next solution. And this is essentially Joel and Marta's proposal. And this is kind of reimagining how application messages are sent. So instead of this secret tree that we have in MLS, where you have like one, which is kind of an inverse of the chem tree, where you have one leaf for each participant, and under each of the leaves you have this ratchet. And instead of doing that, you have a PPRF, so the tree is a bit wider. And whenever someone sends an application message, what they do is they create a challenge, and the challenge includes stuff that disambiguates them from other virtual clients. So let's say it would include the index in the subgroup where all the users' clients are, and maybe the group ID, and all that's hashed so that there's no collision between application messages sent by one client of the user and another client of the user. And then they can use that challenge to derive a key nonce pair from this puncturable PRF. Essentially, the secret tree, they would just go down one path, and the path might be, I don't know, if they have length of the hash function is 32 bits, then 32 bytes, then that would be the size of the tree. And then you arrive at the bottom, you get a key nonce pair, and that's going to be distinct from anything that other clients of that user might use. And this kind of solves both the functional and the security problem, and kind of might make the secret tree a bit more flexible in any case, because you don't have to do the ratcheting anymore, and you still get forward secrecy. But this is not compatible with vanilla MLS. You need a new kind of secret tree design, if you will, and it's also going to require a new wire format. Brendan, yeah.
So one clarifying question, because this is a puncturable PRF, I assume that after you use a certain input pair to the PRF and you get the output, you puncture it so that you can't evaluate that anymore. Does that mean that each client's private state grows linearly with the number of application messages they send? Depending on how the PPRF works, but.
Yeah, and not just the sending client, also the receiving clients, right? I mean, it's symmetric, so everyone would have to puncture it the same way. Yeah, okay. That's a good point. So in that the trade-off is a bit different than the original secret tree. But yeah, thanks for pointing that out. So that's another kind of disadvantage or another trade-off that we're making here. Okay, next slide. Okay, so this is the one that Brendan proposed on the list, and Brendan, feel free to correct me if I'm misrepresenting this here. So here we kind of really split this problem into the functional, kind of how we approach the functional part of the problem and how we approach the security part of the problem. And for the functional part, for now we punt it to the DS and say the DS is going to take care of preventing clients from sending an application message with the same generation and the same epoch and the same sender. And then we tackle the security problem. And well, sorry, maybe to elaborate a bit more, you could do that by either by just kind of tagging onto the MLS message the sender and the generation, which of course is suboptimal because you would leak the sender data that we otherwise would encrypt. But there's more clever ways to go about it. You can hash it and see that there's no collisions and stuff. Yeah, sorry, Brandon, go ahead.
So for the functional problem here of preventing key reuse, I don't think this requires anything necessarily special of the delivery service. Basically, if you have a strongly consistent delivery service, that delivery service already provides you the ability to make sure that you have read all of the messages that have been sent to the group before you send your own message. That's all you'd be doing. You wouldn't have to like get any new metadata that you send to the DS that is outside of what you would normally send.
But it only does that for commits, no? I mean, not necessarily for application messages.
I mean, if you have a strongly consistent DS, then application messages are going to be ordered absolutely. And so a client can go through and see all of the messages that have been sent from their clients and ratchet their user ratchet as far as they need it to.
But that would...
So the DS doesn't have to be aware of it. The DS is just providing an order and telling us all the messages that have been sent, so we can move our own ratchet as far forward as we need to.
But if two clients send at the same time, then like both of them fetch all their messages, and then both send a message at the same time, thinking, "Oh, I have received all the messages. I can." So then you still run into the problem, no?
That is a race condition, yes, but I would argue that would still be solved by a strongly consistent DS, because you've kind of got the ability to read all of the messages and then send your own message. And so if there's like a race condition where someone else could have read all the messages and then like create a fork, then it's not really strongly consistent. I mean, I think in the slide what this says is basically the DS is providing a mutex, which is I can lock the thing, I can read all the messages, I can write mine, and I know that that's serializable.
But isn't that an additional requirement on the DS that we don't like? We have a strongly consistent DS for commits normally, no, right? I mean, this is not in the architecture doc or something that we require the DS normally to do, huh? Or I'm misunderstanding this here.
That's a good question. We might not require application messages to be serialized for strongly consistent DS. I'm not sure.
Okay. Anyway, I think we agree what the requirement is. It's just a matter of is this kind of in the architecture doc, or is this something that the DS would kind of naturally do anyway? Yeah, TKG.
Brendan, maybe you don't want to go away from the mic yet. Brendan, what you were saying sounded to me like you aren't thinking of the DS as part of the threat model here. If the delivery service is part of the threat model in terms of breaking confidentiality, and the delivery service is the one responsible for ensuring that there isn't this simultaneous resend of messages using the same key and nonce, then the DS can simply allow the two clients to send messages with the same key and nonce, and then do its own work to break the shared, this is the key reuse scenario, right?
So that's a great question. The delivery service is responsible for, so you're absolutely right that the delivery service can intentionally not tell you that someone else has sent a message, so that you will encrypt two messages with the same key from two different devices. What that will not do is cause nonce reuse, because of the reuse guard basically idea that I wrote about in my email.
Do you want to quickly explain that, because I didn't get to that yet?
Right. So what different devices will do is they will all guarantee that basically no device will use the same reuse guard. And if you remember from the MLS protocol, the reuse guard is this little 4-byte value that's XORed into the nonce before it's actually used for encryption. So all of the devices that a user has have a different basically space of reuse guards that they're allowed to use. So no two devices will ever choose the same reuse guard, which means they'll never choose the same nonce. And so what you will do is you will have two different messages encrypted with the same key, but different nonces, and that is still secure.
So then we're back in the soup from solution one of if the different clients have distinct spaces of the reuse guard, then isn't the reuse guard then visible to all other peers in the group? Because then that allows the peers to redistinguish the clients unless the reuse guard partition is a secret partition somehow.
That's exactly right. The reuse guard partition is secret. So people who are not in the subgroup that the virtual client corresponds to, they can't look at a reuse guard and see which partition it comes from. And there's also the efficiency aspect of the reuse guard. So with solution one, where you're ratcheting forward through a bunch of keys and not using all of them, that creates an obligation on all the other members of the group to hold on to all of these keys who weren't used kind of in the middle of the ratchet. With the reuse guard approach, you can use one step of the ratchet after the other, and so you don't have this huge set of keys that you need to hold on to.
So that makes a lot of sense to me. Thank you for explaining it. I'm not sure I understand why we need the DS assistance in this case then. Like, why not just the reuse guard?
So the reason that you need the DS assistance is to help avoid key reuse, because without DS assistance, two devices can send a message with the same key at the same time, which will have different nonces, so it's secure, but they'll use the same key, and so each device, when they get the other's message, they will likely have already deleted the encryption key that they used, so they would fail to decrypt each other's messages.
Got it. Thanks. Thank you for the explanation.
Okay. I mean, this was the last slide, so I just wanted to kind of get a feeling with the different trade-offs that we have here in terms of metadata leakage, also vanilla MLS compatibility, and maybe a bit more flexibility with the challenge-based approach. What do people feel is worth exploring? What is covering kind of more use cases? So yeah, just to give us who are thinking a bit more about this problem and trying to maybe come up with a document that we'll eventually maybe adopt, some guidance on where this working group would like to go.
All right, anybody? We can also take this to the list. DKG?
Yeah, thanks. I just wanted to say I really do support this work. I think this is critically important. I think it's a mistake that MLS, as designed, is fundamentally leaking the number of clients and identity of the clients to the rest of the group. So that first use case is, I think, a really important one. So I hope we can work on this as a group to sort out what would need to be done to do that safely.
So just to summarize some of the discussion that we've had on the list already, it also may not be possible for us just to choose one of these, because if you think about the use case of you have one user who has a couple of devices and they want to use all of the devices as one client, what's really important there is you need the privacy aspect of not being able to know which device sent which message. And so that's most likely going to be solution 2 or 3. And then between solution 2 or 3, you would probably, in my opinion, go with 3, just because it's simpler. It requires no changes to the MLS wire format. So that would be nice. But people have also been talking about other use cases for this kind of virtual client subgroup idea, where it's not one person who has a handful of devices. It's maybe like an organizational subgroup. And so you've got like 50,000 people who work in your marketing department or something, and you want them all to be able to be added to a single, marketing mailing list. And in that case, you're going to run out of entropy in the reuse guard. So there's not enough room to fit all of those people in your 4 bytes. And so in that case, you probably would have to go with solution 2 because it has much more room to fit people and entropy.
Those other use cases sound to me like they directly contradict the goals of MLS, in that the goals of MLS are end-to-end encryption among people who can identify who else is in the group. And I recognize those are not necessarily goals that we can describe fully at the protocol or wire format layer. But if the expectation is I'm using MLS, therefore I know who my messages are going to, and now we're talking about messages going to groups that I have no idea who's in them, I think that actually violates the cognitive expectations that we want users to be able to come away saying, this uses MLS, I know what it does. So I'm less keen on those other use cases.
Brendan, are you
Okay.
back? Okay. All right. Well, it seems like discussions will continue. So let's go ahead and wrap this up. Basically take it to the list. And if we can't do that, we can try to have an interim maybe to talk about this particular issue because it keeps coming up and we got to figure out how to decide which one or two to use. So again, thank you for, sorry? Yeah.
Just want to say thanks for the discussion and the input. Thanks.
Yeah, no worries. Thanks for coming out. I appreciate it. I think we're going to bring the meeting to a close. Thank you very much. Yep.
Thanks, everybody.
Oh, and thanks to Jonathan for taking minutes. Appreciate it. Please make corrections. Yes. Rowan and Ecker were going back and forth, and I too was having trouble following. So, all right, cool. All righty. I'm going to try to find some postcards. Apparently, they don't make them anymore. Everyone's like, go to the post office. I was like, really?